Hello, good morning. Hello, good morning.
Good morning, sir.
How are you? Mm.
Sir, please, you are fine, thank you.
Abba,
Please,
Abba, okay. Then Herbert, Dennis. Okay, let me just inform them to join so we take right. Okay, so I'm coming. I'm just reminding them to join.
sing my life.
Hello. Okay, I think we can take off. So this is your usual host, Mr. Bia. In fact, it's good to, meet you once again after that long school break. It feels so good to reunite with the family once again. All right. So let's first look at what I want us to be doing during the time. Before then, a quick attendance check. So I have Faustina, Teresa, Abba, Adjoa, um, Charlotte, Adoma, Asumani, Christopher, Dennis, Herbert, iPhone. iPhone, who are you? What's your name? Oh, your name is iPhone. um, I'm coming in. Let me check it. Stephanie is here too. Okay, Sheila, then Jeriel, Doku. All right. So I want us to be looking at I've in fact your scheme of work was sent to me, and I think I saw electrostatics, calorimetry, heat, then current, electricity. Okay. So what I want us to actually begin with will be on will be waves. Yes, I saw waves too. Waves and sound. So we'll be starting with waves, then we move on to heat, calorimetry. I'm sure you did you were taken through heat 1 in school. Please, did you? Can you hear me?
Yes, sir.
Okay. So we'll take off from calorimetry, then electrostatics. I also saw capacitance or capacitors. Then we look at current electricity. Now, this is what I want to be doing. Whilst we do it, you see, some topics have practical relation, especially current electricity. Current electricity, we connect it with the practicals. Then mechanics, SHM. SHM, we treated it last time. I'll revisit that and then give you the practical application of the theory we were taking through. Today being the first meeting, day, we'll look at moment and apply the concept of moment to practicals. Okay, this is because I think moment questions actually came in WASSCE 2024 this year. And so we'll pick those questions, then apply the theoretical know-how of moment to the practical, so that when you are asked to plot so and so graph, you can be able to tell how the graph will look like. And if you are asked to find some information such as the slope, intercept, and all that, you can be able to do so. So we'll start with moment and look at the practical application to moment. Then we take off with wakes. That is the plan for now. Before we do that, I want to quickly give you a question on moment. Let's look at a question on moment. Then we apply the theory to the practical question which came in WASSCE 2024. All right. So I'm going to draw. All right, please put the question down for me. I'll give you the drawing as we move on. A 1 meter long uniform beam. A 1 meter long uniform beam is hung from the ceiling by a rope. Is hung from the ceiling by a rope and is balanced when a 20-gram mass and is balanced when a 20-gram mass is positioned 30 centimeters from the rope as shown. So a 1 meter long uniform beam is hung from the ceiling by a rope and is balanced when a 20-gram mass is positioned 30 centimeters from the rope as shown. So this is the diagram. I'm going to give you the diagram on the board. This is a 1 meter long uniform beam. This is the rope, which the rope serves as a pivot. So it is connected to the ceiling. Let me bring it down a little bit. Then there is a 20 gram mass here. This 20 gram mass is 30 centimeter from the rope, which is actually the rope is the pivot. This is 60 centimeter. Okay. So the question is that what is the mass of the meter rule? What is the mass of the meter rule? Hey, Festus, please mute yourself. Mute yourself for me, please. So the question is that what is the mass of the meter rule? What is the mass of the meter rule? Okay. Whoever posted the question, please, thank you so much. Okay, so a 1 meter long uniform beam is hung from the ceiling by a rope. So this is the ceiling. This is the rope. And it's balanced when a 20 gram mass is positioned 30 centimeter from the rope as shown. Okay. What is the mass of the meter rule? So I'm giving you 5 minutes to try your hands in solving this question because I want to send the practical question to you so that we go through together. So 5 minutes to attempt this question. All right, so start work for me. What is the mass of the meter rule? Teresa, mute yourself. Let me rather mute all of you. I'm sure you are true. Hello, can we look discuss? How else can we discuss if you are true?
Yes, please. Yes, please.
Okay, so let me get some of the answers you had. Who will start with us? What is your final answer as the mass of the beam? Anybody? Stephanie, what's your answer?
60 grams.
You had 60. Another view from a guy. Ama,
It's also at 60.
okay.
60
All
grams.
right. Okay, so let's see. Let's see. Now, this is a uniform meter rule. Once it's a uniform meter rule, then it means that its center of mass or center of gravity must act at the midpoint. So its mass M must act at the midpoint. And that will be 50 centimeter from the ends. So from one end to where its mass must be, we must have it must be the center of mass must be 50 centimeter from it. Okay, so we have this mass of 20 and then this unknown mass of the meter rule M. So we take moment about the fixed point. This will give us anti-clockwise. This will also give us clockwise moment. All right. So for the anti-clockwise moment, we have 20 grams times 30 centimeter. Okay, to be equal to the unknown mass times what will be the perpendicular distance from the pivot? What will be this distance of the center of mass from the pivot? What will be this distance? Yes.
10.
That will be what?
10
10.
centimeters.
Okay, so look at it. This is 30, 60, giving us 90. It means this end is 10. Okay, so if this is 10, this is 30, 40, then it means from the string, which is the pivot, to where the mass M, its mass M must be 10 centimeter. You got 10 plus 30 plus another 10 would give us 50. So this will be 10 centimeter. So we have M is equal to, this is 600 divided by 10, giving us 60 grams as the mass of the meter rule. So this is what to do. Okay, this is how to approach this question. It's a very simple question. And so this is the way out. There's another calculation. Rama, your hand is up. Go ahead and ask your question. Oh, Era, I can hear you. Please speak
I
up.
was saying that I didn't get the approach.
Okay, let's quickly go over it for the last time. We are looking for the mass of the meter rule. The mass of the meter rule. Okay, this is 20 grams. When you have a uniform meter rule, because it is uniform, then it means the weight or the mass of the beam must act at the center. Its weight, total weight or mass must act at the center. So this being a uniform meter rule of total length 100 centimeter, 100 centimeter. And we are told this mass acts at 20 gram, acts at a distance of 30 centimeter from the string, which is the pivot. So it means from the mass to the string, this distance we are told is 30. This distance from the string, which is the pivot to the end, we are told is 60. So around 30 plus 60, we have 90. So it means from this point to the end, this must be 10, so that we can have that 100 centimeter length of the beam. Are you okay? Now, since this is the pivot, the string is the pivot, we take moment around the string, which is the pivot. Okay. Now, moment is force times perpendicular distance. And this can also be mass times perpendicular distance, because mass and force relate, or weight relate by gravity. Okay, so let's take the moment or the turning effect. So the mass, which is 20, times the perpendicular distance from the pivot, 30 centimeter, must be equal to, and this will give us the anti-clockwise moment. We look for the clockwise moment. The clockwise moment will be the unknown mass m times the perpendicular distance. Now, what is the perpendicular distance? Don't forget, from the end to where this mass is must be 50. Okay, from this end to where the mass of the beam is must be 50 centimeter. Now look at it. This is 10. This is 10. Sorry, 30. This is 10. But from here to here must be 50. So if this is 10, this is 30, making 40. Then what will be the distance from the pivot or the string to the mass? Okay, so if this is 50, and this 2 sum up to 40, this must be 10. Are you okay? So 10. Then you find m. This is 600 is equal to 10m. You divide through by 10, and the mass m will be 60 grams. So if you were not clear, this is the way out to go. Please, I just forwarded a question on the page. I just forwarded a question on the page. Let's look at the last question. The B question. It says that state the conditions of equilibrium for a body acted upon by a number of coplanar parallel forces. State the condition for equilibrium for a body acted upon by a number of coplanar parallel forces. So, coplanar forces, I'm coming. Coplanar forces are forces that act simultaneously on a body. Okay. So if you have parallel forces acting simultaneously on a body, what are the conditions that must prevail for equilibrium to be obtained? Charlotte, give me Give me one of them. Charlotte. Hey, Charlotte, are you there? You earlier raised up your hand. Class, can you hear me?
Yes, please.
Okay. What are the conditions for obtaining equilibrium when you have a number of forces acting simultaneously on a body? Ajua, any idea? Oh, please, it is still the principle of moment you know of. Okay, it's still the principle of moment. So tell me about the principles of moment. What is the first principle of moment?
The sum of clockwise moments equal to the sum of anti-clockwise moments.
Exactly, that is one of them. If you have a beam and you have a number of forces acting on them, okay, and that is the principle we just applied in solving this problem. If there is a pivot and there are forces acting in all directions, this is downward, and there's another one upward, whatever. One, the sum of clockwise movement, this will be anti-clockwise, this will be clockwise, this will also be clockwise, this will be anti-clockwise. For equilibrium to be obtained, the sum of clockwise moments must be equal to the sum of anti-clockwise moments. Okay, or the algebraic sum of the moment or turning effect in all directions must be equal to 0. So that is one of the principles of moment in obtaining equilibrium. What's the second principle? What we are terming here as condition. What's the second one? Herbert, any idea? Festus.
Please, no, sir.
Natalie. Calvin. Okay, the second one is that, Adwa, I think you were ready to tell us. What's the second one? Let's not waste time.
I'm not sure.
So the second one is that the sum of upward forces must be equal to the sum of downward forces. Charlotte, are you there?
Yes, please.
Okay. The sum of upward forces must be equal to the sum of downward forces. And these are the two conditions, okay, that must prevail when you have a number of parallel forces acting simultaneously on a body. Okay. One, the sum of clockwise movement must be equal to the sum of anti-clockwise movement. Then two, the sum of upward forces must be equal to the sum of downward forces. Please, any question? All right, let's look at the next question. The next question says that a body of mass 60 grams is suspended. Hello.
Please, is this question on the platform or we have to write it?
No, it's on the platform.
Okay.
So that's the last information I posted. Charlotte, have you seen it? Class, have you seen that on the platform?
Yes, please.
Okay. So a body of mass 60 grams is suspended at the 29 centimeter mark of a uniform meter rule. Is suspended at the 29th centimeter mark of a uniform meter rule. The meter rule is adjusted on a ninth edge until it balances horizontally at the 44th centimeter mark. The meter rule is adjusted on a ninth edge until it balances horizontally at the 44th centimeter mark. Determine the mass of the meter rule. Similar to the question we've just solved. Similar to the question we've just solved. So determine the mass of the meter rule. So 5 minutes, I want you to collaborate. Please, if you are not so clear with the question, please discuss, okay? Discuss among yourselves on the platform. I'm giving you just 5 minutes to look at it. Afterwards, we'll come together and then solve it. So start work, 5 minutes. It's 10:33, so 10:38, I'll come back to you. Collaborate, I beg you. All right, so 5 minutes, I'll come back to you. Charlotte. Charlotte, did you
Mr.
finish?
Dear.
Did you
Mr. Dear.
finish?
Yes, please.
What did you get as your answer?
Please, I had 150 grams.
150. Okay, let me pick. Herbert, were you able to finish?
Sir, please no.
Calvin, what about you?
So I got the same answer.
All right, 150. Okay, and then lastly, Erama. Erama. Or Era. Okay, maybe she's not hearing me. Stephanie, did you also finish?
Yes, sir.
What
I
did you
had
get?
50 grams.
Okay, so let's quickly go through. A body of mass 60 grams is suspended at the 29 centimeter mark. So I'm taking my 0 point from this end. So if this is the 29 centimeter, this is where 60 gram mass is suspended. Then it's a uniform meter rule. So once it's uniform, then it means that its total mass would act at the 50th centimeter mark from the ends. So this is where M is supposed to be. Yeah, the reflection is taking over everything, but I think it's still seeable. Then the meter rule is adjusted on the ninth edge until it balances horizontally at the 44th centimeter mark. So let's assume that this is the position of the ninth edge. So from the end to where the ninth edge is, we have a distance of 44 centimeters.
Sir,
Now we are to, hello.
answer please, where from the 50?
You see, we are told that it's a uniform meter rule. And once it's a uniform meter rule, then what it means is that its center of mass acts at the center, its total mass. So it means that if I measure what the position of M from the end, it can be both ends. If it's from here, okay, it must act at the middle. So 50, the middle of the 1 meter length, 1 meter, the whole length of the beam is 1 meter, which is 100 centimeter. So once the whole length is 100 centimeter and the mass is supposed to act at the middle or the midpoint, then it will be 50 centimeter from the end. Herbert, are you okay?
Yes, sir.
The reason for which I have the 50 centimeter, it can be either from this end, or from this end. All right. Now, if this is the position of the ninth edge, what will be this perpendicular distance of the mass from the pivot? What will be the perpendicular distance of the mass from the pivot? Yes, Herbert. What will be this distance of the mass from the pivot?
Sir, please 6.
That will be 6. So 6 centimeters. Thank you. So once you have been able to identify all these parameters, then you are good to go. Take the moment. This will give you clockwise moment. This will also anti-clockwise. This will also give us clockwise moment. So 60 times, what is the perpendicular distance of the 60 gram mass from the pivot? What will be the perpendicular distance of this 60 gram mass from the pivot?
15 centimeters.
Adra, come again.
15 centimeters.
1.5. Good. So this is 1.5. Okay, or 44 minus 29. So 15 is equal to M times 6. Therefore, M will be equal to 60 by 15 on 6. And this is equal to 150 grams. Yes, sometimes the thought is that, oh, moment is force times perpendicular distance. Yes, it is true. But whether you multiply force by the perpendicular distance or mass by perpendicular distance, the value will still be the same. You see, over here, if I want to convert this into weight, the masses into weight, 60 gram mass will be equal to 60 times 0.01 Newton. And that will be 0.6 Newton. So 0.6. So if I want to take 0.6 times, then maybe you want to also express 15 centimeter in Newton. So that will be 0.15 is equal to M times 0.06. M becomes 0.6 times 0.15 divided by 0.06. Please calculate it for me. And this will change to F to be force. Don't forget, because we are talking about force times perpendicular distance. What did you get for this? 0.6 times 0.15
1.5.
divided by 2.5.
1.5.
1.5 Newton. So it means the weight of the bar will be this. So if the weight is this, and knowing weight to be mass times acceleration due to gravity, then the mass M becomes the weight, which is 1.5 divided by acceleration due to gravity, which is 10. This is giving us 0.15 kilogram. And when you multiply this by 1,000, 1, 2, 3, this is also equal to 150 grams. So whether you look at it from mass or from weight perspective, the value will still be the same. Any question? If you have any question to ask before we look at the practicals. Okay, let's go to the practicals on moment. Please go back to the question I gave you. I earlier sent. And you see, Adoma, Charlotte.
Mr. Dear, please, which question did you just solve? Because my network.
Hey, which question gave you an answer of 150 grams?
Yeah, that one. Yeah, I get that part. Like, I'm talking about the Newton, the force.
What I'm saying is that, you see, we are taking moments, and you know, moments is the same question though, but because moment is force times perpendicular distance, okay, but over here we're taking the moment as mass times perpendicular distance. So I was trying to explain it using the concept of force times perpendicular distance. Charlotte, are you okay?
Yes, please. Thank you.
All right. You see, as I said, this is a practical question. But do you know that if you understand the concept of movement, you can solve this without actually doing the practicals? You can answer this without actually touching the instruments. And that is what I want you to, know. Okay, when you ask to plot a graph, how your graph will look like, what your slope, intercept, and all that means. So please pay attention. Let's, go through. I'm first giving you the diagram as was given in the main exams question. So the diagram is that, let's quickly go through. It said you are provided with a meter rule, a knife edge, a mass labeled M, set of masses, and other necessary apparatus. I suspend the meter rule on the knife edge as shown in the diagram. So the diagram is a meter rule, of course, a uniform meter rule. It is pivoted at a point G. We are told that this point is G. So suspend the meter rule on the knife edge as shown in the diagram above. Then adjust the position of the meter rule until it balances horizontally. Read and record the position of balance G on the meter rule. Maintain the knife edge at G. You see, if you have a bar, here is a meter rule, and it's a uniform meter rule, okay, then if you want to balance it, because it's a uniform meter rule, it will balance at the middle, the center of mass or center of gravity. Okay, this is the application of this is that if you are carrying a log of wood and it's uniform, for you to be able to carry it easily, your head must be placed at the middle, because that is the point where the total weight of the log would act. If your head is not at the middle, okay, it will be weighing you backward and forward. Okay, so this will only stop when your head is positioned at the middle. So for a uniform beam, the total mass or weight always at the middle, and that is the point where it will balance. So in moving the meter rule to get a balance point, it will definitely balance at the middle. And you are asked to read and record this point of balance, okay, in your, so the point of balance G theoretically will be 50 centimeter, meaning the midpoint of the whole meter rule. Sometimes you can get 49 points or 48 points, depending on the unevenness of the meter rule. But if it's so even, precise, it must be balanced at the 50 centimeter. So this is the point where the knife edge or pivot must be placed throughout. You don't change the position. So the question asks that maintain the knife edge at J. All right. Then the next instruction, suspend M at 30 centimeter mark of the meter rule. So there is a mass labeled M. Suspend it at the 30 centimeter mark. A mass labeled M, and from the end to where this is, it must be 30 centimeters. Apiadum, are you there? Yaba? Or they are not here. So suspend M is capital M, not small m. So suspend M at 30 centimeter mark of the meter rule. Then from the other side of the knife edge, suspend the mass small m, which is 50 grams, and adjust its position until the meter rule balances horizontally. So at the other side, we have to suspend a mass labeled as small m. This has a mass of 50 grams. Now what you have to do is that you adjust the position. You move this 50 gram mass around, so it balances. So it means that we don't specifically know the balance points until you do it. So D is unknown. So all that has to be done is that we have to move it about. We have to move this mass till it balances on the meter rule. Please, class, I hope you are following.
Yes.
Yes, sir.
All right. Now the next instruction. So suspend the mass small m, which is 50 grams, and adjust its position until the meter rule balances horizontally. Then read and record Y. So this is not actually D, it's Y. Read and record Y. That's why I said we don't know this. So all that we do is that suspend a mass of 50 grams and move it till it balances. And then you read and record Y. Calculate Y inverse. Repeat the procedure with small m, which is equal to 70. So we are starting with 50, 70, 90, 110. Then lastly, 100 and 120. So we are only varying this one. This is the position of the pivot. Then this mass fixed. We are only changing this mass to move it around so we get a balance point. Okay. And then we are evaluate Y and tabulate the results. Now back to, I earlier said that you can actually do this without doing the experiment. You see, during exams, what we do is that, you see, we are varying this small m, but this one is fixed. So what we do is that we actually cover this mass with a sellotape. Okay, that paper sellotape, and then would label it as M. Class, honestly, during exams, if you are smart to remove the cover, you will see what mass it is. The moment you are able to see the kind of mass, you are good to go. You can do the experiment without actually touching anything. Because from this illustration, this is 30 centimeters. What do you think will be this distance? If this is 30, what will be this distance?
20
centimeters.
So that will be 20. So if you take moment, you have M times 20 is equal to small m times Y. As for small m, that is the control one. We are always varying that, so we know. But we will sort of cover this one. And this is a standard mass. The mass is already known, written on it, but we are only covering. So if you could see it, you can easily determine why. For each M50, 20, assuming in this year's exams, this M was 50. This M was 50. So 50 times 20 is equal to first M, which is 50 times Y. Straight away, you could see that the balance point of 50-gram mass would be 20 centimeters. So it means if you begin with 50 grams, then you must place this at a distance of 70 centimeters from the pivot, and you can balance the whole arrangement. Please, is that okay?
Yes, please.
For 70, you have 50 times 20 is equal to 70 times Y. Y is what you are looking for. Y is 100, this is 1,000 divided by 70. And you have 100 on 7. What is 100 on 7? 100 divided by 7.
14.29.
So 14.2. Now, when you are using calculations, Amma, what did you get? What value did you get? 14 point what?
29.
Come again, 2 what?
9. 14.2.
You see, here the issue is that if you are doing this without actually doing the experiment and you write your y value this way, you are caught. I can be able to tell you that no, this girl did not do the experiment. For writing this value, I can be able to detect that you didn't do the experiment. Can somebody tell me why? Can you tell me why in writing this, you give the clue that you didn't actually do the experiment? Adam, Charlotte. Charlotte, I'm listening.
I think because on the meter rule, you can only find. I think because on the meter rule, you can only find it in one decimal place.
Thank you. On the, you see, y must be determined on the meter rule. And on the meter rule, the least is 1 millimeter or 0.1 centimeter. So the least count must be 1 dp. So once you are recording this, straight away, it tells me this is a calculated value. So you must be very, very careful with. So the best way out must be 14.3 centimeter. That's all. So usually what we do is that we try to hide one by covering and labeling. We'll cover and label one. Okay. But if you are quick, so when you are doing this, this is the reason for which when you are doing this and we pass by and you are wrong, we can see. Because I know this value, which is covered. So I'll use this theory just to see the accuracy of the values of y you are getting. And that is all. Please, any question before we move on to the next? All right, then let's move on. Charlotte.
Mr. Diaz, so please, all that we are doing is like a rough work, right?
I'm giving you a clue on what you can do, okay, during such experiments. We are actually doing this, getting a value of y without actually doing the experiment. And all that you need is this unknown mass m. When you know, you can get your y value because the practicals is all about getting y. It said read and record y, okay? Then calculate y inverse. Repeat the procedure with m is equal to 70 up to 120. In each case, read and evaluate. You read y and evaluate y inverse. Then tabulate your results. The other question is that what goes into your table of value? You have masses. As for big M, it is fixed. It's just one mass. So it will not show in the table of value. So M/J. Then you need Y/centimeter. Then the next question is that you evaluate Y inverse. So Y inverse /8 units. This is the composite table, the least possible table you can have. Sometimes there is this double measurement kind of thing. So some students will want to take double measurement. In that case, what they do is that it's like measuring twice to be just to be accurate with their results. So y1 / centimeter, y2 / centimeter, then Abba.
So please, I wanted to ask, since the big mass, the fixed one will be covered or something. So how will you find that one by yourself?
What I'm saying is that sometimes you can just, if nobody is looking around, you can just remove it and watch. Then you cover. It's just this
So if
paper
not,
solid tape. Pardon?
so if not,
Then
like
you
if
have
you are
to.
not,
Then you have to do the experiment. We are using the theory, knowing this, to just find our value of y. But if you don't try to be smart to know, then you have to really do the experiment. Okay.
yes, sir.
Then y inverse / centimeter. This is a possible table of value. Another one. Blanche, your hand was up. Hello, Blanche. Christopher. Okay. So this side goes with the masses 50, 70, 90, 110, and then 120. The moment you indicate the unit here, you don't need to repeat the unit. The reason for which we have the unit up here, so that it saves you from repetition. Now, this is a standard mass, a given mass, a kind of mass you are not to weigh using an instrument to measure. The reason for which there is no decimal place written, they are given masses. Okay. Now with y1, knowing m, big M, we calculated y balance point to be 20. So 20.0, 1 dp, because of the least the meter rule measures. Then 70, for 70 gram mass, we had 14.3. Okay, 90, blah, 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 when you calculate. Y2 must be almost close to this or the same. If it is the difference is too wide, then it means it is wrong. And this is the reason why we take double measurement, to reduce error, to be accurate in our measurement. Because when the difference is too wide, it will draw your attention to the fact that there may be something is wrong. So y2 must be a value which is equal or close to the first one. Then you find the average. So over here, the average, if it's the same, the average will be the same. Now, you see, look at something. The average is in 2 dp. The reason is that the average value is a calculated value. 20 plus another 20 divided by 2. This isn't a value I had using any instrument. It is a calculated value. So each dp must be different from using an instrument. The reason why this is in 2 dp at least. Then y inverse. Y inverse is another calculated value, 1/20. Okay, so in order to distinguish this from this, I will express y inverse in 3dp. So 1 divided by 20. Please give me 1 divided by 20 in 3 decimal places.
0.050.
0.050. That's all. At least 3dp. So this is what goes. And if you also decide to eliminate y1, y2 and go straight in determining y, you are also correct. Okay. The advantage this has is that if you are able to take double measurement, you can use that as a precaution that I took double measurement in order to eliminate error, possible error. So it's taking double measurement is actually a precautionary measure. Precautionary measure. So you can use that as precaution when it shows up in your table of value. If you don't do that in your table of value, you cannot write that as a precaution. Please, any question? All right. Now let's. Hello, Charlotte.
Please, the y to the power -1.
Y inverse.
Yeah, y inverse. Thank you. Please, why did you leave it in 3 decimal place?
You see, it is another calculated value, and I wanted to create that distinction from the average.
Okay.
Just the average is this plus z divided by 2, but this is actually 1 divided by the y average value. So to create that distinction, the reason for which this is expressed in at least 3dp. At least means that it can be more, but when you write it in more decimal places, it's like littering around. So at least 3dp. Remind me to send you a soft copy of a practical guide where you read to get all this, right? Then the next question is that plot a graph with M on the vertical axis and Y inverse on the horizontal axis. Starting both from the origin. Okay, so we are plotting a graph of M on as the vertical, Y inverse as the horizontal, starting both from the origin. What does this actually mean? So all that we are doing is that we are going to plot a graph. This graph must be such that the vertical must be M, small m slash G. Then the horizontal is Y inverse value. We are to start both axes from the origin, meaning we must not break the axis. So 0, 0. Right? Let me adjust the screen well. So both graphs must not be broken. Okay, so if you are taking every 2 centimeters to be 0.5, then this must be 0.5, 1, 1.5. If you are using every 2 centimeters to be maybe 0.2, then 0.2, 0.4, 0.6, 0.8. It must be orderly. You cannot break it. That is what starting both axes from the origin actually means. Please, any question? All right. Now, you can also use that. Okay, yeah.
Sorry, I went off, but then why is the mass now in like decimal places?
No, I'm assuming. Ideally,
Okay.
these are the M values. So it's a good question. It's a good question. Meaning, these are my entries. So my least mass is 50. My maximum mass is 150. So based on this, I'll use this to choose my scale. Then, okay, let me go for, let every 2 centimeter be 50. So 50, 100, 150. This will not help because the maximum mass is 120. So you vary. Okay. If it's 20, so 20, 40, 60, 80. So you have your 120 mass. So Charlotte, that is it. You choose your values with your figures. So there's no way it will be few. All right.
And please,
Please,
I have another question.
Okay.
Okay, please, the Y2, I don't know how Y2 was derived.
Y inverse, this one.
No, Y2 on the table.
Oh, you see, the Y2 is a double measurement, the same balance points, but you want to measure it twice so as to eliminate possible error. The reason why we do that is that sometimes in your first measurement, you may think you are right. You take it again and you realize there is difference. So that will draw your attention that perhaps something went wrong in your first measurement. So whenever you take double measurements, it enables you to eliminate possible error. Are you okay?
Yes, please.
Era?
Thank you.
Okay, welcome. Era, go ahead, ask your question.
Since we are doing the practicals, and then the capital it will be covered with a tape. So
yes,
we can check out like the mass of the
you can even remove to check and then cover afterwards.
Yes, please, but then like would there be a chance that you have to show working of how to get the M so that you derive the Y?
You see, what I'm saying is that this is a smart method of doing it without actually touching the equipment. That's what I'm saying. So if I want to be smart and to, go around the system quickly, then I use the theory instead of doing the practicals. And it will give you the same results. That's what I'm saying. Are you okay?
Yes, please. But then I'm just wondering, like, if you want to find the Y, and maybe you don't know that you're supposed to, like, that thought doesn't come to you that you're supposed to remove the tape to check out the mass of the capital M.
I'm a teacher who is involved in practical, so I am telling you what you can do. Do it in a way that you wouldn't be seen doing it. That's all.
Yes.
All right, so let's look at how this graph will look like. Even when you haven't plotted, you can still check how your graph will look like. So pay attention and let's use the theory to see how the graph would go. So we are told that plot a graph with M on the vertical and Y inverse on the horizontal, starting both from the origin. Now, theory. The theory we are actually applying is this. We are using the principle of movement, and that is what we use to even determine Y when we haven't touched it. So the principle is that, are you there?
Yes, please.
Okay, so M times 20, because this is fixed, this position is also fixed. We are not varying it. So M times 20 is equal to small m times Y. And we are to plot M against Y inverse. So what I'll do is that M is a y-axis. Equation of a straight line. Y is equal to mx plus c. The y-axis must be made as the subject. Here my y-axis is m. So I will eliminate y. So divide through by y, and now m, small m, which is the independent variable here. The y stands alone. So y is equal to, m is equal to 20 big M over y. But over y, I can write it as y inverse. This is the equation of the graph. Now I compare it with equation of a straight line, which is y is equal to mx plus c. Yaba, are you there? Oh, Yaba is gone.
Please, I'm here.
Okay. When you compare this with equation of a straight line, you see, the m is your y-axis. The horizontal axis is y inverse. So this is x. Then it means that the slope or the gradient m, when you compare, is equal to 20 big M. When you compare, it also means that the intercept on the vertical axis C is equal to 0 because there's no value here, plus nothing. So C is equal to 0. So I have even managed to figure out the value I must have as the slope. We'll come to the slope question. Slope, which is the gradient, theoretically must be equal to 20 times big M. Now, this graph means that, you see, in equation of a straight line, if you have an equation given by y is equal to mx plus c, then your graph must look like this. This is the point where the graph cuts the vertical axis. If you have an equation and it is y is equal to mx minus c, your graph will look like this. It means that it's a positive graph, but the graph cuts the vertical axis at the negative. So over here, let me clean some parts to illustrate this well to you. So if your equation is such that it is mx minus c, your graph will look like this. It's a positive graph because the gradient m is positive. But your graph will cut the vertical axis at the negative, minus c. So this is c. So this is cutting it, y is equal to mx plus c. This is y is equal to minus c. And if the intercept is 0, then your graph must actually start from the origin. Your graph must look like this. Start from the origin. This is y is equal to mx, just mx, where c is 0. And when we derive the equation, that's the kind of graph we are getting. M is equal to 20 capital M times y inverse. Intercept is 0. So your graph will look like this. Please, are you okay?
Yes, please.
So I've just used theory to figure out how the graph will look like. And this is telling me that the graph is an equation of a straight line starting from the origin because intercept is 0. You see the power of theory. We are using the same theory to do that. Then the next question. Determine the slope S of the graph. Determine the slope S of the graph. So after drawing the graph, you pick any 2 points to find your slope. Change in vertical, change in horizontal. So since the y-axis is M, and then the x is y inverse. This is change in M, change in y inverse. So the slope S is equal to delta M on delta y inverse. When we use the equation, we saw that M is equal to 20 capital M y inverse. And this, because we compared it to equation of a straight line, which is mx, we saw that then the gradient or the slope will be equal to this. So this must be equal to 20 times capital M. So after drawing your graph and determining the slope, your slope must be equal to this. What does it mean? You see, Eura, I earlier told you that you can be smart to remove the tape to see the magnitude of that mass. So if the mass is 50, then it means that my slope must be 20 times 50. And this must give you something close to 1,000. So if you understand the theory and you could figure out the mass, then you can know what you must get as your slope. Charlotte, any question?
I'm lost.
Ask.
Um,
Charlotte,
Okay, my first question is, why is it that in
okay.
the equation we didn't make y the subject so that like you see over here is y is equal to mx plus c. So why is it that
Yes.
in our equation we didn't make y the subject but we made m the subject?
Charlotte, the reason is that you are asked to plot a graph with M on the vertical and then Y inverse on the horizontal. Okay. Meaning that
See.
your y-axis is changed to M and your x-axis is also changed to Y inverse. So it is like being relabeled. The axes are being relabeled as M and Y inverse. So when we compare that to equation of a straight line, if you have a graph like this, this is Y, this is X, right? So when you draw a graph and it's like this, it simply means that the intercept is 0. So this equation becomes Y is equal to mx because plus c, but c, because c is 0, this changes to be 0 and it's like this. In our context, the graph is labeled not as y, not as x, but m, and my x-axis is y inverse. So if I'm drawing an equation, then it will be m, which is y, is equal to the gradient. Let's use another letter for the gradient, n, but the x-axis is y inverse plus c. But because the graph starts from the origin, C is 0. So it's just a relabeling of the axis from the traditional Y and X. Charlotte, are you okay?
Yes, please.
Okay.
Thank you.
All right. So that is, then the next question is that evaluate after determining the slope. Evaluate K is equal to S over 100. Yes. All right. I got S to be 1,000. So this is simply 1,000 over 100. And so K will be 10.
10.
That's all. So we are only using the theory to determine all that. Then the last question is that use the graph to determine the value of Y when M is equal to 85 grams. So look at this. I want somebody to help me out here. How do we answer the question? You are giving M to be 85 grams.
Is it capital M also?
Small m. M is equal to 85 grams. Use the graph to find the value of Y. We can actually use even the equation, but this one, the question insists that you use the graph. If you are using the equation, we have an equation which is M is equal to 20M Y inverse. So it is more or less like giving M 85. Okay, I know the value of big M to be 50. So, and this is when you have figured out the value of big Y. So we have Y inverse is equal to 85 over 1 over the slope. Okay. So
Yes.
1, 2, 3, 0.085. 1, 2, yes. So if Y inverse is this, then don't forget Y inverse is 1 over Y. Stephanie, are you there?
Is
Adua and Co. So if
Yes, please.
Y inverse is this, can't you easily find Y?
Yes, please.
The other way, if you want to use the graph, and the question insists that you use the graph, then your 20, 40, 60, 80, 100, you locate 85. 85 will be here. So 85, you trace it to the curve, and it will give you the corresponding Y inverse. So you read from the graph. Whatever the graph gives you, okay, Y will be equal to
11.
1 over the value you had. Please, are we okay?
Yes, please.
Now, let's use the theory to also understand this value of slope. What does it mean? This is what we got for the slope. The slope is theoretically is 20 times big M. Let me write it down here. Big M is the mass of the covered mass. What is 20? 20 where again? What is this value of 20? Herbert, are you there? Christopher. The guys, let me hear from you. Kelvin. Jariel. Or they are gone.
No, sir.
Let me hear your voices, okay? Please. I said M is the covered mass. What of this 20? This value of 20. You can refer from the diagram. You can refer from the diagram. What is that value of M? That 20 centimeter value.
Sir,
It's,
please.
Go ahead.
sir, please, the distance between big M and the pivot.
Thank you. So it's the perpendicular distance. So if we have the perpendicular distance and then the product of the perpendicular distance and then the mass, what do you think this value of M actually means? What does it mean? What is it?
Sir, please, the value of M will be the 30 plus the 20.
We said, no, I said M is the covered mass, which in this context is 50. So it is like 50 times 20. But what is this value of 50 times 20? What is it? Yeah, Stephanie.
This, I think, is the moment.
It is the moment. It is the anti-clockwise moment of the mass M. So the slope stands for the moment or the turning effect of this mass M. Are we okay?
Yes, please.
That the slope of the graph stands for the turning effect of this mass M. That's all. Charlotte.
Please, is it always like that?
Oh, you see, the issue is that I'll give you another question. Those things you are asked to find in the questions have reasons. They have reasons. Okay, so if you understand the theory, we are using the theory to even deduce whatever we are asked to calculate for. We were asked to calculate for S, and we've just seen that it's like mass times perpendicular distance, and that is moment. So it is the turning effect of the mass M. Okay, so we will answer another question. Okay, I will even send it to you so that you go through it yourself, because we have barely 20 minutes to end. But that's another question which we have to answer. And if we are able to do that, in fact, your understanding of this practical thing and the moment will be very, very easy. Is that clear?
Yes, please.
All right. Please, if you have any question, ask before I send the other Alt C's practical question or moment to the house. Amma.
Sir, please, so what if the intercept, which is C, is greater than or less than 0? Would they ask a question that will involve
You don't worry. This second question has that. So here the intercept is not 0. And so we'll go through it and then you answer it yourself. I'll even send it to the group. So let me forward that to the group so that you go through it as well. Please, I'm coming in. Let me pause the recording.